So yesterday we wrote the expression for force according to the Coulomb's inverse square law. F is equal to P into Q1 Q2 by R square. We called this as equation 1, and this force will be directly proportional to the product of charges and inversely proportional to the square of the distance, and will always act along the line joining them. That is a statement. And in electrostatic units, in medium, P value will be 1 by K, and in vacuum, P is equal to 1. So you will be getting force in dynes. From that, we got K is equal to F naught by F. Means we can define dielectric constant also as the ratio of force between 2 point electric charges for the given separation in vacuum to that of a medium. That ratio we can call it as the dielectric constant. We also got a very important point that when a medium with the dielectric constant K is introduced in between the given pair of electric charges, then the force between them will get reduced by dielectric constant times. That's what all we did yesterday. So in SI units, P will be 1 by 4 pi epsilon 0 in medium, of course. So the electrostatic force of repulsion or attraction between the 2 point electric charges will now become 1 by 4 pi epsilon Q1 Q2 by R square. But epsilon R is equal to epsilon by epsilon 0. This implies epsilon will be epsilon or epsilon 0. Therefore, the force becomes 1 by 4 pi epsilon or epsilon 0 into Q1 Q2 by R square. So if the charges are located in vacuum, one implies are located in vacuum, then K is equal to epsilon R will be equal to 1, and the force is F naught given by 1 by 4 pi epsilon 0 into Q1 Q2 by R square. This you can take 3, and this as 3a. So if you substitute the value of epsilon 0 here, 1 by 4 pi into 1 by 36 pi into 10 to the power of minus 9 into Q1 Q2 by R square. This is 9. So I get F is equal to 9 into 10 to the power of 9 Q1 Q2 by R square. So many newtons. So you can write the equation 3. Three can also be written as, this is F naught. F is equal to, for problems, 9 into 10 to the power of 9 by K or epsilon 0 into Q1 Q2 by R square. Next, we'll get the definition of Coulomb. If Q1 is equal to Q2 is equal to Q, R is equal to 1 meter, and F is equal to F naught is equal to 1 by 4 pi epsilon 0. That is 9 into 10 to the power of 9 newtons. If you substitute in this, you will be getting Q is equal to 1 coulomb. So a point electric charge which repels a similar charge situated in vacuum at a distance of 1 meter from it with a force of 9 into 10 to the power of 9 newtons is defined as 1 coulomb. I repeat once again, the point electric charge which repels a similar charge situated in vacuum at a distance of 1 meter from it with a force of 9 into 10 to the power of 9 newtons is called 1 coulomb. This method is adapted. We consider boundary or limiting conditions in a given law or statement to define the unknown quantity. This is a general method we adapt. Yeah, please take it.
Sir, could you please give the definition of Coulomb again, sir? I would like to note it down.
Yeah, you can write the point electric charge. The point electric charge which repels a similar charge situated in vacuum at a distance of 1 meter from it with a force of 9 into 10 to the power of 9 newtons. With a force of 9 into 10 to the power of 9 newtons, comma, is called a unit charge of 1 coulomb. Is called a unit charge of 1 coulomb. Completed?
Yes, sir.
Yes, sir.
Okay. Next, epsilon. So from the equation 3, we can write the formula for epsilon as Q1 Q2 by 4 pi into FR square. So SI unit, Coulomb square, Newton inverse, meter to the power of -2. Of course, already we gave another unit, Farad meter inverse. Both are of equal. Dimensional formula, charge is IT, current multiplied by time. So Q1, Q2, I square T square, force, ML T to the power of -2, R square, L square. So this will be M inverse L to the power of -3, T to the power of 4, I square. So this is how we can write the units and dimensional formulae of the permittivity. Next, we have a pair of charges Q1 and Q2 at a distance R1. Then the charges have become capital Q1 and Q2 at a distance R2. The force of attraction or repulsion between them is F1 here, and here it is F2. Then, assuming that they are in the same medium, then F1 by F2 is what key matter then? Q1 Q2 by capital Q1 Q2. Nenu kuda vachindi. R2 by R1 whole square. Please copy down. No, I requested you to call me after 5 o'clock. I am in class now presently. Please. So F1 by F2 is Q1 Q2 by capital Q1 Q2 into R2 by R1 whole square. For the given pair of charges, of course, we'll get F1 by F2 is R2 by R1 whole square. Since F varies directly as 1 by R square, that is R to the power of -2, we get delta F by F is -2 into delta R by R. So delta F by F into 100 is -2 into delta R by R into 100. Say for example, if distance between the given pair of charges decreases by 2%, then percentage change in the force. So it is -2 into -2 because it is given decrease. So 4% increase means if the distance is decreasing by 2%, then the force acting between the pair of charges will increase by 4%. Yeah, this relation is to be remembered. Simple only. Even you can expect some problems based on the ratio. I didn't remember exactly when AEEE was there, the ratio was asked. In place of JEE main, there was the AEEE. In that exam, this ratio formula was asked, not a problem even. Completed, eh?
Sir.
Yes, sir.
Okay. Next, sixth. In hydrogen atom, there are standard results, and you have to remember the electrostatic force of attraction between the nucleus and hydrogen, that is given by 9 into 10 to the power of 9. Let us put Z, we'll equate it to 1 afterwards. ZE square by R square. Next, the gravitational force between the nucleus and electron, 9 into 10 to the power of 9 into ZmH, mass of the nucleus, multiplied by mass of electron by R square.
Sir, gravitational force means 6.67 into 10 power minus 11.
Yes. I'm thinking something. 6.6 into 10 to the power of minus 11. Yes. So this is a nucleus with the Z protons. Here is electron. The mass of nucleus is ZmH and mass of electron is Me. R is the radius. Charge on the nucleus is plus Ze. So if you divide them, this Z by R square will cancel. So I get Fe by Fg. $90 by 66 into 10 to the power of 20 into E square by 1837 Me square, because MH is 1840 or 1837 times the mass of electron. This is 6 15s, 6 10s. So Fe by Fg is simplified formula 15 by 10, 6 15, 6 11, sorry, not 10. Into 10 to the power of 20 into E square. General formula I am writing MP Me. So if you substitute the values, (2.56) into 10 to the power of minus 38 by 1837 into 81 Me square into 10 to the power of minus 62. So this is 20 plus 62, 82, 10 to the power of 44. So I can rewrite it as 15 by 11 into 2.56 into 100 into 1000 into 10 to the power of 39 by 1837 into 81. This is nearly 6 times it will go. 1000 by 1837. Oh, sorry, not 6 times. You keep 2560. 2560, 2.56 into 1000. 2560 by 1837. So nearly 1.4. Yeah, 1.5 means it goes up to 2.7, 2700. So it will be around 1.4. 2.56 thousand by 1837 will be around 1.4. 100 by 81. 81 ones 2. So 15 by 11. How much? 11 ones, 11 threes. So nearly it will be coming out to be around 2 into 10 to the power of 39 you will get. Nearly, nearest value. 2 point something you will get. So please do the actual calculation and let me know tomorrow. Okay. Don't
Okay,
do
sir.
with calculators. I can also do that. Do manually, just for memory. So from this we
Okay,
can
sir.
say that the electrostatic force is nearly 2 into 10 to the power of 39 times stronger than the gravitational force between the nucleus and electron. The electrostatic force is 2 into 10 to the power of 39 times stronger than the gravitational force. Okay.
Between proton and electron also.
Between
Protons and
nucleus and electron and hydrogen atom. Even for other atoms also, this Z will cancel.
Sir, then A will come. In nucleus, neutrons also will be there, no, sir?
Neutron mass, yeah, for heavier nuclei.
Yes, sir.
Yeah.
Except for hydrogen atom, all other atoms have neutrons, no,
Yes,
sir?
yes.
Then AMHME will come, no, sir?
Correct.
Sir, what is the 1837, sir?
Mass of proton is 1837 times more than electron. Na?
Oh, yes, sir.
How can you forget basic things? Finished?
Yes, sir.
Yes, sir.
Okay. Next. Seven, 4, 7, right?
Yes, sir.
Yeah. Please write the given charge capital Q. The given charge capital Q is divided into two parts. And are kept at certain fixed distance R. The given charge capital Q is divided into two parts and are kept at fixed distance R, small r. What should be the ratio of these two fragments? What should be the ratio of these two fragments? So that the force between the charges will be maximum for the given separation. Force between the given two charges will be maximum for the given separation. So let us suppose Q1 is equal to Q Q2 will be capital Q minus small q. Then the force between them, constant P into Q1 Q2 by R square, constant P into Q into capital Q minus small q by R square, that is P by R square into capital Q minus small q minus q square. Here the variable is small q. So for force to be maximum, that only is asking.
Derivative of 0, sir. Yes, sir.
It is given that for what should be the ratio for force between them to be maximum. So for F to be maximum, variable is small q here. df by dq
Should be 0.
becomes 0. So we'll get d by dq of capital Q minus capital Q multiplied by small q minus q square should be 0. So this is q minus 2 into small q is 0. Therefore, q is equal to q by 2. Means the given charge should be divided equally. And if these two segments are kept at any fixed distance, then they attract or repel with the maximum permissible force. They are to be remembered. Finished?
Yes, sir.
Next. 4-9, huh? Is it 4-9?
4-8.
Okay. Yes. The region between the given 2-point electric charges, please write. The region between the given 2-point electric charges is filled with composite dielectric slab, a composite dielectric slab with dielectric constants K1 and K2 with the dielectric constants K1 and K2, comma, each respectively filling the space in between the charges. Each respectively filling the space in between the charges.
Sir, each respectively.
Filling the space in between the charges through the distances R1 and R2. Through the distances R1 and R2. Then what is the force between these two charges? So what I mentioned is this. You're having two charges Q1 and Q2. at separation small r, such that if no medium is there, then the formula will be 1 by 4 pi epsilon 0 into q1 q2 by r square. If the complete space is filled by single dielectric, then it is 1 by 4 pi epsilon or k into epsilon 0 r square. So I can rewrite this expression as one by 4 pi epsilon 0 into q1 q2 by root k into r whole square. This is 9 into 10 to the power of 9 q1 q2 by r square. This is 9 into 10 to the power of 9 q1 q2 by root k r whole square. So you can interpret it in other way. With the introduction of dielectric slab between any pair of charges which were already existing in vacuum, we can assume that R1 is equal to R. Effective separation can be assumed to be increasing to root k into R. Since R2 is greater than R1 implies F2 is less than F1. This is physical interpretation. Now, how to apply this to this particular problem? So it will be F is equal to 9 into 10 to the power of 9 into q1 q2 by, because two dielectric slabs are there, it is root k1 r1 plus root k2 r2 whole square. If half of the space is filled with dielectric and other half is vacuum, then we can write it as 9 into 10 to the power of 9 into q1 q2 by r1 is r by 2, r2 is r by 2, so that I am taking common, r square by 4 into 1 plus root k whole square. So thus it becomes F is equal to, it is 9 into 10 to the power of 9 q1 q2 by r square is f naught. So it is 4 f naught by 1 plus root k whole square. Relation based questions may come like this. So initial force without any medium between them is f naught. Then I assumed that only half of the space, sometimes 1/3, 2/3, like that they can ask anything. So if the half of the space is filled with the dielectric and other half is vacuum, then the formula becomes 9 into 10 to the power of 9 q1 q2 by r square by 4 into 1 plus root k whole square. So thus I'll get f is equal to 4f naught by root of 1 plus root k whole square. This is composite dielectric slab. You can do problems based on this. Here I took half. It may be 1/3, 2/3, 2/5, 3/5, anything they can ask. So important relation. Completed?
Completed, sir.
Okay. Four nine. We have, say, like charges, unlike charges. Q1 and Q2. They may be positive, they may be negative. Q1 is positive, Q2 is negative. Then F is equal to P into plus Q1 into plus Q2 by R square. Here F is equal to P into minus Q1 minus Q2 by R square. So in either case, here between like charges, it is repulsive force, and repulsive force is regarded as positive force. Next, coming to this, F is equal to P into plus Q1 minus Q2 by R square. So between unlike charges, there will be attractive force and attractive force is regarded as negative force. Okay.
Sir, 1 minute, sir.
It's just a convention we adapt.
Completed, sir.
Okay, good.
Completed, sir.
Then the next and very important, Coulomb's inverse square law in vector form. Because force is vector, you should be able to express the force expression, whatever you are writing in vector notation. So here, this is the space, and here a positive charge, here is a negative charge, the position vector of q1 is r1 bar, and the position vector of q2 is r2 bar, and the force between them will be acting along the line joining these two charged bodies. Because it's repulsive, so it acts away from each other. So this is the position vector r bar joining these two charges. So from the mathematical knowledge, vector addition, we can write r bar is equal to r2 bar minus r1 bar, and modulus r is modulus of r2 minus r1. And one more thing, the electrostatic force between these two charges q1 and q2 will act along r bar, implies if you want force in vector form, then you can multiply the magnitude of force with
The unit vector along the direction.
unit vector along the force direction. So unit vector along the force direction means the vector along the direction of force is r bar. So this is the force. So I can write it as F naught bar is equal to modulus F naught into whatever unit vector we are assuming, that is r bar by r. So unit vector of r bar is r bar by modulus r, that is r2 bar minus r1 bar by modulus of r2 minus r1. So we get F naught is equal to 1 by 4 pi epsilon 0 into q1 q2 by r square into r bar by r. So 1 by 4 pi epsilon 0 into q1 q2 by r cube into r bar. Therefore, you can write it as F naught bar is equal to 1 by 4 pi epsilon 0 into q1 q2 by r cube simplified format into R bar. It can be also written as 1 by 4 pi epsilon 0. I will write another line. Okay, please copy this first. So this is how we express the Coulomb's inverse square law in vector form. Completed, huh?
No, sir.
Even expression came in the exams. So therefore, F naught bar is equal to 1 by 4 pi epsilon 0 into Q1 Q2 by modulus R2 minus R1 whole cube into R2 minus R1 bar. So this is the Coulomb's inverse square law in vector form. Okay,
Yes, sir.
Yes, sir.
good. Others, no one is talking. They are understanding or just passive listeners? Hmm? Vivek Sai kept log. I too came, but you're all youth. Huh? Good. Keep it up. We'll continue tomorrow, right? Akshita? Following the class, ma? Akhila? Tanusri? Fine. Okay.
Thank you, sir.
Thank you, sir.
Bye. Bye-bye. Good.